plus some arbitrary constant. I wanted to choose your mother as the constant, but it doesn't work because my chalkboard is way too small to contain your mother on here. Let's choose your dog as a constant. Good morning, fellow mathematicians, welcome back to another video. I'm back, obviously, that's why I'm standing here, and we're going to deal with this one today in preparation for something else, just like the last one, but this time it's actually quite an exciting one. It's a pretty cool integral in my opinion, and not obvious how to solve this on the first sight. So we are going to dive right in. So you see, this time it wouldn't make sense to introduce a substitution like t equals to this thing right here. It wouldn't really make any sense. But what would be good is to introduce some substitution, trig substitution in this case. So for example, if we would substitute the tangent into here, we have tangent squared plus 1. Okay, this doesn't really factor nicely, so that we would get, for example, tangent squared plus 1 would be equal to secant squared, so square root of secant squared would just be secant. So we have to play around a little bit with this. How can we do that? Well, why not introduce a substitution where we could in fact factor out this 2 right here? Because 2 is positive, so we could break up this square root in the end. Okay, follow my thought process here. What would happen if we would introduce a substitution, namely let x be equal to square root of 2 times the tangent of t. And if we differentiate that, we end up with dx being equal to square root of 2 times the secant squared of t dt. Okay, you see, this would be actually quite good, because if we plug all of this stuff in, we would end up with, well, on top we would have this right here. So square root of 2 secant squared of t dt. And down here we would have, well, this is square root of 2 squared is nothing but 2 times tangent squared of t plus 1. And down here in the third we would have nothing but, well, square root of same spiel as here, so we have 2 times tangent squared of t plus 2. Okay, fuck off dt, go here. Okay, you see, and this was exactly my point, because now we can factor out this 2 right here, and we end up with square root of 2 times the square root of tangent squared plus 1, which is nothing but the square root of our secant, which would be, in a normal case, the absolute value of secant, but we just don't want to talk about that. So we are going to just evaluate this as the secant. So what we have now is, let's bring this square root of 2 to the outside, square root of 2 times the integral of secant squared of t. Like I said, we have 1 over square root of 2 now, so bringing this to the outside, this is just going to cancel out in the end. Over. And now we have 2 times tangent squared of t plus 1. And we also have the square root of secant squared, which is nothing but secant of t dt. And you see, this and that is going to cancel out nicely. And what we have by now is nothing but integral of. And let me rewrite this a little bit. Secant is nothing but 1 over cosine. So we have 1 over cosine of t over. And now we have 2 times. Tangent is nothing but sine squared over... Oh, so tangent squared is nothing but sine squared over cosine squared. Excuse me, I just came back from vacation. Over cosine squared of t plus 1 dt. And you see, now we can just factor out this 1 over cosine squared down here. So that means we have 1 over cosine squared, which is nothing but cosine squared. Multiplying this by 1 over cosine is nothing but cosine in the numerator. I hope you could follow all of what I just said. So we have integral of. Up here we have the cosine of t over. And now we have 2 times sine squared of t. And we also have plus cosine squared, because we have factored out this 1 over cosine squared. Okay, so most of the stuff is already done. That was quite easy. And you see, if you would break this up, this denominator is nothing but sine squared plus sine squared plus cosine squared. But you see, this right here is nothing but 1 by the fundamental theorem of trigonometry. And, well, this simplifies our denominator by quite a big margin. So we have the integral of cosine of t over sine squared of t plus 1 integrated with respect to t. And now it does make sense to actually introduce another substitution. So for example, let's be fucking badass today. Once again, let gamma be equal to the sine, because sine differentiate is nothing but cosine. We would get rid of this stuff right here. So let me get this bitch boy up here. So let gamma be equal to sine of t. That also means that d gamma is nothing but cosine of t dt. And we can plug all of this stuff in to end up with an integral of, well, this is just d gamma in this case. And we have over gamma squared plus 1. Cool. This thing right here is nothing but the inverse tangent of gamma. That was a fucking ugly looking parenthesis. I'm terribly sorry. And gamma is nothing but the sine of t. So we end up with the inverse tangent of sine of t. But we are not completely done yet, my boys, because, well, this is not our original x. So we have to get back to the x world, like Steve would say. So remember that our x was nothing but square root of 2 times the tangent of t. Well, we can divide both sides by square root of 2. It's not equal to 0. So that means that tangent of t is nothing but x over square root of 2. And you see, tangent is nothing but opposite over adjacent. So if we take a look at a right triangle, so we have this angle t right here, and we also have opposite over adjacent. Okay, and we also have our hypotenuse right here, which is nothing but square root of, then we have x squared plus square root of 2 squared is nothing but 2. And, well, now we can find the relationship between our opposite and our hypotenuse, being just our sine. So that also means that sine of t, it's actually equivalent right here, because it's on an interval from 0 to pi over 2. Never mind. So sine of t is then nothing but x over square root x squared plus 2. We can plug this in. So that means if this thing right here is our original, let's call it J for Jens, the mathematical meme guy. Jens is nothing but the inverse tangent of x over square root x squared plus 2 plus some arbitrary constant. I wanted to choose your mother as the constant, but it doesn't work because my chalkboard is way too small to contain your mother on here. Let's choose your dog as a constant. Yeah, a dog with 6 legs, 2 tails, and motherfucking bunny ears and a fucking cool nose. So this is our arbitrary constant chimera, I would say. Looks fucking ugly. I thank you guys for watching. If you did enjoy this video, please like and subscribe and recommend the channel if you like. Share those videos everywhere. It helps the Flammable grow. Also, if you want to support the channel a bit more, buy those stupid ass t-shirts I created or support me on Patreon. Anyways, I love you guys, appreciate ya, and up until the next video, have a bug, dog, chimera, mouse, Pinocchio day. See ya. Colombia.